Okay, so this is my first time teaching in this lecture hall, so I'm fairly new to this lecture hall. So my name is Peyton Chandarana. You can call me Mr. Chandarana, my first name even, I don't care. Really, I am a PhD student in computer science and engineering. I got my bachelor's of computer science and engineering here in 2019, so not too far or long ago. I started my master's. I decided to stay, pursue my PhD. And so now I'm here teaching. I'm also, don't call me doctor. I'm not a doctor yet, like getting there, right? So don't let that fool you into thinking that I don't know my stuff either, though. But I'm not a doctor. Don't call me doctor, please, or professor. Those are titles to be earned. So yeah, please call me by my first name or address me Mr. Chandarana or whatever. So yeah, I got my degree here in 2019 in computer engineering. I stayed for a master's for about 2 years, kind of floating around labs and doing things around the department. And now, since I'm a PhD in the ICAS lab, we work on hardware and AI acceleration hardware specifically. And specifically, I focus with neuromorphic computing, which is like the brain-inspired version of AI or machine learning. And that's kind of things I deal with and everything like that every day. So if you're in here, you're for trying to learn Unix and Linux, it's probably a prereq for your 240 course or whatever. If not, you might be from another department. Quick show of hands, who's in computer science and engineering? Okay, so most of you. Who's not in computer science and engineering? Okay, so we got a couple, but I hope that this will be valuable to all of you. I thought it was. It was taught much differently than it was when I took it a couple years ago, than it is now, for better or for worse. So yeah, I think regardless of what discipline you're in, this class helps a lot, especially if you're a 240 going into 240 soon, which is in C++. You'll, I think, appreciate this class. So we'll quickly kind of go over the syllabus real quick. To get to the syllabus, so we're not using Blackboard. I don't know how many of you are familiar with the Dropbox site for the department. So if you're not in the department, you probably don't have access to this website. So please email me if you don't have access to this site. So it's Dropbox at csce.se.edu, and it's Unix Linux Fundamentals 215 80x whatever. Many of you might see two sections of this. We're using the 80x. There's like 5 different lab sections. So please use this one. I don't think you can see it, but if you see multiple versions, make sure you're on the right version. And so all the course is going to be taught and hosted on this website. It's easier, in my opinion, than Blackboard. I think students like it a little bit better. It's obviously changed a little bit since the summer, but yeah, so you can find the course syllabus. We'll have announcements here, which you'll also get sent emails. If I send an announcement here, then you'll get sent an email. Lecture slides will be in here, and then we'll have lecture videos, I think, hosted on YouTube. So everything's going to be posted on YouTube, even this lecture. And then, yeah, we just kind of start from there. We're here, so I think you know the time. There are 5 different lab sections, 801 through 805. They're all on Wednesday. I will be instructing all of them. So they're 50 minutes each for 20-minute breaks. We do have a TA. I'll get to her in a second. But yeah, there's 5 different lab sections. They're just down the hall in D Wing right here. And it's an Linux lab. You just go in there. There is a code to get into the actual room, which is this code, unless they've changed it recently. So, and then, yeah, so you're going to show up twice a week to this course, one to this lecture on Mondays, and then your lab that you were in and registered for on Wednesdays. All right. So again, I'm Peyton Chandarana. That's my email, PSC. Really not very, hopefully not too hard to remember. I do have planned to have office hours right after this class, as well as on Fridays maybe. I'm going to kind of gauge to see what's best for the class, as well as what works best in general. So like I said, we do have a teaching assistant. Her name's Alale Torjazi. She is a remote TA. She's going to be doing mostly the grading. So when you get a quiz or an assignment back or a homework back, you'll probably get graded by her. And she's going to have remote office hours on Microsoft Teams on Tuesdays and Thursdays at those times. All right, again, please use the Dropbox website. That's where we're going to have everything. Don't go to Blackboard and expect to see it. I'm not using Blackboard. And don't email me assignments, please. If you email me an assignment, it's going in the trash bin in my inbox, or I'm just not going to look at it. So don't email me assignments. If the assignment link's not up there, then that's my fault. But yeah, don't email any assignments unless I specifically have a circumstance that you need to email it to me. So yeah, all course materials will be on that website. Again, if you're not in the computer science and engineering department and don't have access to this website, please let me know as soon as possible, because you won't be able to access the labs either. And then we have to go through a whole kind of mess. Another thing is, typically if you're a transfer student, they sometimes have issues getting you an account. So if you're a transfer student transferring in, please email me too, just so that we can make sure everything's set up for you. All right. What?
I noticed like at the start of every semester, I log into Dropbox until I change the email or the password.
Okay. Yeah. Yeah. So again, there's some troubles. If you can't access something, please email me so we can get that fixed out as soon as possible. So as of now, I have 4 types of assignments. Well, 5, I guess. We have quizzes, which will be held about every other week. This says every odd number. I may change it to even. I don't think I'm going to give a quiz this week, because there's not really much I can give a quiz on, but we'll see. Quizzes, they're weighted heavily. And the reason I weight these heavily is because I want to know what you know. Like, the class is a lot of commands and a lot of things you're going to learn in this class. So you have to learn a lot of things. So the quizzes force you to study, right? I mean, I hated them, but they always forced me to study and learn the material and learn it well. And I mean, the quizzes aren't going to be ridiculously hard. Some of them might be more challenging than others, but they're there. Don't worry too much about them. Just try to practice, or really this class is about practicing. So the more you practice in the Linux labs, the better off you're going to be. The more times you're going to be able to sit in front of things and get things done quicker and snap, memorizing, and just things are going to be muscle memory. So you'll have lab assignments every lab. Some of these will be just copy paste what the output is into a text document, upload it. That's probably what this week's is going to be. I'll just tell you what to do. You'll copy paste the results and send it to me in Dropbox. So lab assignments are more or less an attendance grade to some extent. I will make sure you actually tried at your lab assignments, that you didn't just show up and submit a file. That didn't do anything. It doesn't do you any good. You will have only a couple of homeworks. I'm thinking right now I have 3 to 5 planned. These homeworks will not be things that you have to use the Linux labs for, so you don't have to worry about setting it up at home or whatnot. They're more or less going to be like, describe a scenario when you use blank. So they'll kind of be more abstract kind of questions. This also prevents cheating, which I'll get to in a second, to some extent. You will have a final exam. Right now, I don't think the university has a final exam specifically scheduled for this class. So right now, I've tentatively scheduled it for like basically the last day of class, in the last lab. So yeah, and I do plan to have one thing I didn't put on here is a midterm. I found during the summer when I taught the course that students lost a lot of things that they learned in the beginning of the semester towards the end of the semester. So the midterm tries to make sure you kind of study and memorize and get enough practice with the first beginning material so I can assess it and figure out what I need to recover if we need to. All right, so course outcomes. Again, this is basically learning how to do Unix and Linux command line stuff, basically how to look like a hacker, if you will. The grade scale. So grade scale is basically the standard grade scale. Just notice, again, the weights. The quizzes are weighted pretty heavily. Homeworks are weighted really heavily. Midterms equal to quizzes and homework, and final exams 30%. Again, I made labs pretty much an attendance grade. So if you show up to labs and try, you get 10%. Okay, so this is a tentative class schedule. Provided nothing happens, maybe hopefully we won't have what was it called? Hurricanes or something again, like I had when I was here in the falls. So yeah, this is a tentative schedule. I have the notes of when the homeworks will be due, midpoint in the semester, when the final drop date is, so you can have those in mind. All right, so this is where we get to academic integrity. This course has been notoriously bad about cheating. I don't condone it at all, and like no professor should. If you're cheating, as my professor says, my advisor, there's something wrong with the way I'm teaching something, or maybe I'm not going in depth enough, or maybe you don't feel confident enough to come to me and ask questions. I don't know, but it happens. If you feel like you need to cheat, come to me and ask questions, right? Like, or the TA. Don't cheat. Like, I'm not kidding. I'm good at catching people. I've seen the tricks. I've been a TA. I've been a professor or instructor, excuse me, quite a few times now, and I know how to catch it. I have programs that I can run to catch it. I can just read it and know it's happening. So please don't try to cheat. Like if you have the inclination to cheat, please contact me first. Like, don't go ahead and cheat. I'm going to make it very hard to cheat in the class. You shouldn't be able to, or it's going to be very difficult for you to cheat. One, because we're building on material, and I'll know. 2, because a lot of the resources out there are the same ones I know of, and so on. So please don't cheat. And I want to give specific like emphasis to the penalty if you're caught cheating. Like, if you get caught the first time, you get a 0 on the assignment and a whole grade letter deduction. So if you're at a B, you go down to a C immediately the first time. The second time, you fail, right? I'm being harsh because I'm trying to give you every opportunity not to cheat, right? This is very harsh. The professor that taught this, I think a semester ago, you get caught once, you're out. You fail. So I'm being a little bit lenient, giving you, if you do for some reason cheat, again, I'm not condoning it. I'm giving you a chance to make up for it. So you have a chance to learn from your mistakes. So attendance, I'm not going to be extremely strict on attendance in here because I'm going to be posting the lectures. But in labs, I highly encourage you to make all of them if you can. We will be doing valuable things every lab to help you practice and learn these commands and learn Unix, Linux as well as you can so you can go on to 240 or the next class. So I'll probably take attendance in the labs. I'm not taking attendance here because, again, lectures are recorded. I plan to also have a Teams meeting link at some point so people can join in remotely if you're sick or can't make it one day. So you can join in. But outside that, please come to the labs. I mean, I'm going to be doing them personally for 5 hours on Wednesday, so I'm putting in a ton of effort, so please come. So normally TAs would be assigned, and TAs would be teaching the labs, but I'm doing it for 5 hours straight. All right, late assignments, 3 days after the original due date, but each day you're late is 10% off the grade. After 3 days or after 30% off, it's counted as a 0. So keep that in mind with your assignments. Again, there's not going to be very many outside homework assignments. Most of the things that you'll do in this class can be done in the lab outside of the homework. And there's only going to be like 4 or 5 homeworks. If you have disabilities and you need some kind of accommodation, you can reach out to the Student Disability Center, and they can help coordinate that with me so that you can get the resources and accommodations you need. So, and then finally, this course help. This is outside of disabilities. If you need extra help and it's not a disability related accommodation, please reach out to me if you feel like you need some kind of a separate accommodation. Like if I need to be louder in class, if I need to record lectures differently or something like that, or upload things ahead of time, we can discuss these things. As far as like using resources like online resources for the course, the internet is the big one, right? Everything you do in this course can be searched on Google. All the assignments that used to be in place, they can be searched on Google how to complete them. Or you can go on Stack Overflow and type it in and somebody will answer for you in a week or something, or a couple of days. So I very well know that everything can be searched on Google. So that's why I'm structuring the courses like I am. So yeah, if you need extra help, you can reach out to me, the TA, come to our office hours, look up on Google, ask your CSCE peers. Just again, don't copy, don't cheat. But like if I have to define what cheating is, then something's wrong, right? Copying, making your even the people who make their assignments publicly available, like on GitHub or something, or Stack Overflow or something like that, you're at fault too, because you're letting people cheat off of you. So, okay. So, yeah, I think I've emphasized cheating enough. I expect none of you to cheat this semester. I want 0% cheating, because trust me, it's a huge pain for me too. I have to fill out paperwork. I have to go to meetings. It's a huge ordeal for you and for me. Okay. So that's basically the syllabus. Before we do this history and introduction and stuff, again, Dropbox, you go in, you can log in, everything will be here. A quick thing is in the labs, you'll start learning Unix, Linux, command line, and using the operating system in general. It's just like any other operating system like Windows or Mac OS or whatever. Everything that we do in the class has to run on those computers in the Linux labs. If they don't, or if your solution to a problem does not work on those Linux labs, then how do I know it works, right? If it only works on your system, it's not really a solution, right? Because you can install 15 different programs to get something working, but then it doesn't work on somebody else's system. So again, Linux labs, please check that your solutions work on there. they should work on there because that's what I'm going to be using to grade, and that's what the TA is going to be using to grade, because we have to have a reference machine of some sort. So these labs are remote accessible, but you have to go through a couple steps. So if you go to resources on the computer science, like csce.se.edu website, there's this resources tab. And then if you go to Linux workstations, all of these are computers in the Linux labs that you can access remotely. So I'll give you a quick tutorial of how to like access them. You're gonna have to learn it on your own. I mean, I could teach it to you, but in past years, we've spent way too much time learning how to remote access these machines. So if you want to learn how to remote access or remote access into the lab, you should learn it. I have a tutorial or guide on Dropbox that I've already uploaded, but I'm not gonna hold your hand doing it every single time. You are responsible if you want to remote into the labs to learn it. So yeah, all these computers can be accessible, and you can get the codes. Normally there will be a login screen right here. I'm already logged in, so you see the codes. But if you need the access codes for the Linux labs, you can log in on this page as well and get them. But yeah, so these are all the machines that you have access remotely. All right, and I'll show that at the end as well. I think that's it as far as, oh yeah, so as far as recordings go, this is my lab's website. If you go to teaching on this icastlab.com, you'll see CSCE 215 Linux fundamentals, and I have a lecture playlist that will have the slides and the lecture with them. If you go to all lecture videos, it'll take you to a YouTube playlist. So we're iCast Lab on YouTube. Yeah, and then also on Dropbox, there's a link as well if you want to get to the lecture videos. So you go here, and then you click on YouTube, and it takes you to YouTube. Same thing. Okay. All right, I'm going to try to blaze through this introduction kind of PowerPoint. Okay, why did you do that? All right, so a quick history introduction. A lot of you might know a lot of this already, so bear with me. Some people may not know or may find some facts interesting. All right, so first thing is, if you're thinking you don't need or math for this degree or for computer science or engineering, you're kind of wrong. You have to have it. Like mathematics is the foundation of computer science and engineering. It is very important. I know this as a PhD student because I use math and have to practice using it all the time. But everything you do in computers, even if you want to be just a website developer, for example, you have to know how to do math at some points. Calculating how wide pixels are, or how many pixels to make things, how to make a circle or whatnot in web development. Even the edge cases or the non-computer science or academic kind of jobs in industry use math at some point. So please don't fool yourself into thinking you don't need math. So a quick start with some important people. Ada Lovelace, a lot of people don't know, was one of the first digital programmers, right? So back in 1852. Now hers was very mathematical. It's nothing of what we think today, but she was able to come up with the first kind of program per se to run digitally on a machine. And her colleague, Charles Babbage, built the first digital computer. And when we say digital computer, it's something like that with the little gears, wheels, and whatnot. Then we have Alan Turing in 1954. So we did a nice 100 or so, almost 100-year gap. He was fundamental in finding, he is kind of the god of computing to some extent. And there's more of them, but he is one of the, like everything with the Turing machine. If you've heard about the Turing machine, all of our programming languages and computing resources and everything could technically be based off of his original idea of a Turing machine. And he also was kind of the founder of AI to some extent. He was the first to kind of come up with the Turing test, how to know if something is sentient or not, and kind of coming up with something that would actually solve problems in a more clever manner. And then John von Neumann, he came up with the many things. One thing he's very well known for is the von Neumann architecture, so the hardware architecture or idea of having a CPU, calculate everything in the CPU, process it, store it in memory. So anytime you have like, okay, there's RAM and memory and the CPU, and it loads and stores things to compute, that's partly his contribution. All right, so another thing about analog versus digital. You have two types of computing, well, three now with quantum computing. You have analog and digital, where kind of the foundation. Analog is kind of where it started. For a long time, it was kind of archaic. People thought analog computing never going anywhere. It's coming back now because it can solve some problems that are, it's much better at solving problems than digital, for example. So you have continuous computing, things that need mechanical or continuous computation instead of discrete, like binary zeros and ones. So again, digital, analog differences. You got switches and on and off, ones and zeros, versus analog is like a continuous, like think of if you know electronics, voltages, how voltages change. Everything's continuous when it comes to voltages and currents and stuff. And then if you really want a good example of where analog and digital can kind of shine, think of how floating point numbers work. So if any of you've taken digital logic design, you know that floating points or decimal numbers are zeros and ones, but they're very intense operations on a digital computer because it's not supposed to be continuous based. All right, so digital foundations, we start with switches, on, off, 1, 0, high and low. So these are transistors, which are the foundation to pretty much everything computing. These transistors create not and all these different gates and logic we know of. And then everything transistors goes to gates, and then gates get turned into arithmetic ALUs, or arithmetic logic units, that can do all your math and everything. And these are all the foundations of what you're used to in your computer. Everything that you do boils down to these three things in hardware. Goes down to the ALU, goes down to the gates, goes down to the transistor level. All right, so history about input, output. So we've always had input output, going from switches, like plugs and switches, like turning on and off manually, to punch cards. My mother was actually somebody that used punch cards. She told me good memories of her walking down the hallway in college with her punch card stack and falling and tripping, and then boom, all your punch cards are out of order. You have to sort through them again to get the program to work. So thankfully, we don't have to do that anymore. Keyboards, obviously, you know what those are. Mice, like there's a good history of different input and output. Okay, so this is where things are going to start getting interesting for you, because I might blow some of your minds. So in your previous programming courses, you're used to hitting a button to run your programs, probably. You see a green play button, you press button and magically works or doesn't work. You either get an error or it succeeds. So in this class, as well as in your next class in 240, you'll learn how not to use that button every single time. So you'll actually learn what things happen under the hood when you hit the green play button to make your program run. And so this is kind of based off of what language you use too. So when it comes to languages, you kind of have two different types. You have interpreted or compiled. There are advantages and disadvantages to both. In general, compiled are usually faster. You compile it and you get a program out and it just works. Versus interpreted is reasonably kind of slow because it has to, you're giving it input as you go. You're kind of feeding it a Python program as you go, and it just kind of progressively runs those things in a script manner. But there's advantages to things like Python, interpreted languages, in that they're pretty intuitive and good for prototyping. But when you need something really fast, you usually go to compiled languages. So you got Python versus C++. Python's interpreted. C++ is not interpreted. It's compiled. And this brings us to the abstraction of how programming languages work. So most of you have learned probably one programming language, probably, and that's a high-level language. That's one that a human can read easily and program easily in. These are both Python or C++. They're both high-level languages. And then at some point, they're compiled one layer down to what's called assembly language. This assembly language is still human readable, but it's boiled down to the very basic instructions. So add, subtraction, jumps, all these different instructions. So it's just the basis mathematical and computational elements. And then from there, they go through an encoding layer, which they're encoded into binary. No one can read that. If you can read binary, like, tell me, because you're a genius. Yeah, so we have these three different levels of abstraction. This is what happens when you hit the green play button. You go from high-level language, you compile into an assembly language, and then you run it with the binary code on your machine. So we're going to learn these three steps at some point in the semester. And you're going to see why there's a benefit to knowing the three steps versus just hitting the green play button. And then, yeah, if you look to the right, you can kind of see the flow of how things go as far as compiling and linking and whatnot. All right, so now we get to operating system. So all operating systems are a big while true loop. They're just big loops that run continuously. Also, I forgot to mention, if you have questions, please raise your hand. Please, I don't mind. So operating systems are just big loop programs. They just keep looping forever. You can do stuff with them. Why do they exist? They're really there to manage usage, hardware usage, and to help you program things, right? Like, no one wants to program things in binary or use just the good old, I guess, DOS or punch cards, for example, where you just feed in a program and it learns it or reads it. So it really helps you with easy programming. That's what operating systems are. They let you use the software. It handles all the I/O, handles all the processes, math, whatever. But there's different approaches. So before, you probably heard about Mac OS. A lot of you are using Macs. I'm using a Mac. Some of you use Windows. Here's a third one, Linux. So the superior of both of them, as you will learn in this class. So we start out with Unix, which was written in assembly. Yuck. I hate to be the person that did that. Way back in 1969. Then it kind of changed into what's called Unix-like operating systems. So that's why you get, I guess, the L in Linux, I guess, or LI. And that was founded by Linus Torvalds. He's still alive today. He's rather very smart, but he knows how to speak his mind. But he's a very well respected because he's came up with the Linux kernel, and he's kind of pushed the Linux project ahead. And then you have BSD. So BSD is another kind of operating system. It's based off of Unix. So it's not Linux, it's Unix. And then we have MS-DOS, which is its own little thing that we don't talk about. Because it's its own thing. It's not based off of these three at all in most ways. So MS-DOS was precursor to Windows, and then we have Mac OS, which was built off of BSD, and then we have Windows, which was built off of DOS, And then we have our Linux distributions. So these are the ones that are here today, most of them. So we have Ubuntu, Arch Linux, Debian, Fedora, Red Hat, CentOS, all these different distributions, different flavors of Linux, but under the hood, they're very similar. They all are this Unix-like based system built off of the Linux kernel that Linus Torvalds created. So obviously, Unix, Linux fundamentals, we're focusing on Linux. All right, so a quick kind of, I guess, visualization. So this gives you an idea of kind of the family tree, per se. So we got tons of different stages where things have gone in different directions. So you'll see that everything starts from this unnamed PDP operating system. It goes down to Unix, and then everything kind of flows down from there. So this little dotted line shows where Unix-like systems or Linux systems started. So we got all these different Linux things, but Unix is still over there. And if we even look, where is it at? Mac OS is right there. So it trickles up to BSD and whatnot. So Mac OS is very similar to Linux, not exactly the same. All right. And then we have our distributions of Linux. So we're just going to zoom out if I can. I guess not. Let's see. I guess I'll have to do it manually. I'm just going to zoom out. These are all the distributions. Well, a lot of them at least, of Linux. They've just been forked time and time and time and time and time again until like who needs any more distros of Linux, right? But there's still new ones coming out that are actually really nice. And they all do their own little thing. But they're all based off of the Linux kernel for the most part. And then we get to the point of how are all the Linux-based operating systems similar? So the biggest thing when I was an undergrad learning this is I was confused about what the kernel was, what the shell was, how they were different. So this gives you an idea of how your Linux operating system works. It has your hardware, everything, resources, whatnot. Where is it at? Here? Yeah. Human interfaces and hardware, all these things. And then they go through the Linux kernel. So when you hear the kernel, you think of a little layer that you can't necessarily interact with. You can, but we're not going to do it. That handles all your resource utilization, common day-to-day like RAM allocation, things like that. So this is like the base form of software to get your computer even running something. And then we get to the shell. So the shell is like the software layer on top of it. I like to think of it as like a text-only software layer for the most part. And then you have all the software that builds around the shell or whatnot. You're fine.
I did not mean to click that.
You're fine.
Click something else.
So, all right, so we get to, this is kind of what I was trying to describe. We have a hardware layer in the center. We have the kernel built around it that supports the drivers, utilization, hardware utilization and whatnot. We have the shell around it, which is what we're going to be focusing on. And then you have all the software, GUI software, whatnot around that. All right, so what is this class about? So I've already said it, the shell and the command line. So everything you can do for the most part in a GUI, like a graphical user interface where you click around and use a mouse, can be done on the command line. In a lot of ways, the command line saves you a lot of time. I think in certain circumstances or certain aspects of this semester, you'll find that it's much quicker to do things on the command line. So another thing is how to get rid of your mouse, how to throw it out the window. So basically how not to ever leave your keyboard. You can keep your hands on the keyboard and never leave. How to automate things to make your life easier. And then obviously how to save time. So you don't have to keep doing the same thing over and over or clicking the menu, drop down, whatnot. And then most importantly, how to look like a cool hacker in an airport or something. Somebody looks over their shoulder and is like, oh, what is that guy doing? Oh, he's hacking somebody. So yeah, you'll look like a hacker to some extent. Okay, so any questions? Please don't make me talk more. It's a lot. And I also, during the summer, it was a 2-hour or so session per day. So I just condensed this into like 20, 30 minutes. So, okay. So I promise you a demo at the beginning about how to remote in. So this will kind of give you an idea. In the Linux labs, your shell will not look like this. So like I've customized it and made look really pretty and have little like nice little information here and there. We might learn at some point at the end of the semester how to do this, or I'll give you maybe a supplementary information about how to do stuff like this. But yeah, so you'll have a command line in the Linux lab, which you'll have like a blinking cursor. And you'll try to do things with it, like clear. What does the clear command do? It just clears the terminal. Do ls, okay? If you know anything about Mac, you have these are all directories, right? You have your downloads directory, your library, movies, music, whatever. And then if we do some things a little bit more complex like ls-l, oh, there's more files. So they're hidden. They start with a dot. This will be a recurring theme. If we do ls-l, you get more stuff. So I got these, whatever these are, and then this, you get more information. So you'll see this is, I mean, read, write, execute. You got, this is my username, whatever group, and then you have the dates and times which things were modified. So we get information. Okay, well, clear, because I don't like all of it. And then you can create a directory. So now if we do ls, we have hello directory. Okay, well, here's a new command. Use cd hello, so change directory. And now we are in hello, the hello directory. Okay, what if I want to know where I'm at any point in time? pwd for print working directory. So it says I'm in users S7117 hello, and so on. So we're going to learn a ton of commands. I know this might be like, oh my gosh, how am I going to remember all these abbreviations or commands? Well, you will. You'll practice. It just takes a lot of practice, is all. And it's a lot of muscle memory. So as promised, I'm going to teach you how to do the remoting in. So SSH stands for secure shell. And then we pass in -p 222. And then your username for the university. Again, I'm going to have a guide to this on Dropbox, so you don't have to worry. You have your username, and then you have an @ sign. And then if we go back to our handy dandy page, we just copy one of these. We get this IP address, the 129 ending in 174. We go back to our terminal, paste it in, press enter, and it shows you a message saying something about authentication. It says yes. Then it says this system is used for authorized users, yada, 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 and ask you for your university password. We do my university password. All right, notice something. I just typed. There's nothing in the terminal, right? It doesn't show asterisks, doesn't show text, nothing. Passwords in general in Linux, when you type them on the command line, they do not show up. So you'll just get this key, even though I have something typed here and I press enter, and it says, okay, now do dual factor. It didn't show anything, but something was there. So don't get discouraged if you don't see text when you start entering your password. It's reading the text that you're entering, but it's just not showing it for security reasons. All right, so now I'm in the Linux labs. I am on one of those computers in there, down the hall. And you'll have something very similar to this when you log in. You'll have a $ sign and you'll start entering commands like I was earlier. So it's the same exact thing from earlier. If I do ls, you can see the files and directories. If I do cd and go into one of the directories, then now I'm in the repos directory with another directory inside of it, and so on. So all these commands have analogs in their GUI version. Like cd is like double clicking on a folder. ls is like opening File Explorer, right? Or Finder if you're Mac. So all of these have analogs. Like we're learning how to do stuff with the keyboard instead of with the mouse at this point. But that's more. We're going to learn more than that. We're going to learn, again, how to make things faster, how to compile stuff. In general, just make life easier, in my opinion. I think using the terminal is a whole lot easier than clicking a button. So yeah, I'll have a guide to how to remote in. On Dropbox, please email me if you do not have access to Dropbox. And I will see you in the lab on Wednesday.